Hello?
Professor, I think Farishta lost your connection.
Oh, you have a problem with the connection? So can anybody else do it?
I think Farista already did it.
Oh, okay. So that's fine.
Professor, can you start recording?
Yeah, I did.
Thank you.
Okay, so now that you have random variables, there are two types of random variables, discrete and continuous. And I hope you know what a discrete variable is and what a continuous variable is. Can anybody tell me? Can somebody tell me what is a discrete and what is a continuous?
Professor, discrete variable, they take some isolated values, and in continuous variable, they take values within a certain range.
Yeah, in a certain range. But discrete is basically integer values, okay? It can take some integer values and mostly. And then the continuous variable, as you said, yeah, it's over a range. The values can be over a range. So then we talked about the mean and the variance. Mean of a discrete random variable. Mean is also called expected value. And this, remember, this is a population mean, not any sample mean. So we are talking about the population mean of a discrete random variable expected value. And we did one example of finding. Did we do this mean expected value in the last class?
Yes,
Yes,
Professor.
Professor.
So we found it, and I asked you to find the mean of the another random variable. Anybody checked to find the mean of this random variable? Did anybody try? It looks like nobody tried. How do you find the mean of the random variable? Let's do it here. This is how you do. You multiply the value, each value by its corresponding probability. Okay. So each value, now we are trying to find the mean of this very random variable y, which is also a discrete random variable. How do you find the mean? This is how you get the product of each value of the variable with the corresponding probability. So what do you have here? Can anybody check?
1/13.
Uh,
It's one.
It's
yeah. If you guys did it, I don't have to do it again, or else we have to do it. You guys have to be active in this class. You have to do whatever homework we give you. Remember, that way only you can learn. This is a heavy duty course. If you don't, if you think you will do very well staying a couple of nights before the exam up, no, this is not a course. So what you do is to find the mean, you multiply each of the values with corresponding probability, and if you add this column, you get the mean. Expected value of y would be this column sum. Can anybody give me the value of this summation?
It will be 7.
It will be 7. How do you know it will be 7?
Yes. Professor, I summation all y multiplied py
Oh, you added.
answer. Yeah, yet that I got it.
Okay, if you are, if you
Yes.
give me assurance, then I can take it.
Professor, it is 7.
It's
I was
7?
surprised. Yeah.
Okay. Yeah. Okay, if it's 7, then the mean is 7. Okay. All right. I'm not sure whether that's right or wrong. So you know how to find the mean of a discrete random variable now? Everybody? Hello? Yeah. So, hello?
Yes, Professor, you can hear.
Yes, Professor, we can hear you.
All right. Thank you. I was blocked out. Yeah. So, now we know how to find the mean of a discrete random variable. It's basically summation of the variable times the product of the variable times the probability. Let me check.
Professor,
Yes. Yeah.
Professor, you said you said a statement earlier like mean is a discrete variable. Can you explain?
Yeah,
that
this is a
again?
discrete variable. Yeah, here.
Like, is mean a discrete variable? Is it not a continuous variable?
This is the mean of a discrete random variable.
A mean of a discrete. Mean is not a discrete variable.
No. Hang on. So
Okay.
you are now confusing. The variable is a discrete random variable. Okay. This variable y, is it a discrete or continuous variable?
Discrete.
Discrete variable. If the variable is a discrete random variable, then this is how you find the mean of that variable. Okay.
Okay.
What is the confusion?
I misheard a statement. That's my fault. Sorry, Professor.
Pardon me?
No, I misheard a statement. I thought that you said mean is a discrete variable.
No.
That's wrong.
Mean
That is mean of a discrete variable.
Mean of a discrete random variable. How do you find the mean of a discrete random variable? This is how. The value of the variable times its corresponding probability. So this is a product, okay? Variable times probability, and if you add this column, you get the mean of that discrete random variable. The formula is this: x times p of x, and is also called mu. This is also called a mu. A mu is a parameter. What is mu? Mu is the population mean of a random variable or expected value. Population mean is a parameter, it's not a variable. Please note this. Population mean or population variance are parameters, not variables. So these are population mean, not sample mean. Now, how do you find the variance of a random, discrete random variable? Here, so again, we did this mean in the last class. And here we are trying to find the variance of discrete random variable x. How did you find? The variance of x, also denoted by sigma square x, Greek letter sigma square x, is nothing but expected value of x minus mu whole squared. X minus expected value of x minus mu x whole squared. Now mu means expected value of x, which we already know, which is 2. And so what are you going to do? You are trying to find expected value of x minus mu whole squared. Same rule. Here you found expected value of x. How did you get? You multiplied each value of x by their corresponding probability. Here also you multiply x minus mu whole squared Can you hear me?
Yes,
Hello.
Professor.
Okay. A very unstable internet here. So, so now you the same rule applies. X minus mu whole square is again treated as a random variable. So you find the expected value of x minus mu whole squared. This is a straightforward, direct way of doing things. Later on, we will have an indirect one. So x, probability of x probability of, I just copied this column, okay? I copied this column. And then I added one more column, two more basically. First one is x minus mu whole squared. What is first x? First value of x is 1 and mu x is 2. So 1 minus 2 whole squared. 1 is the value of x, 2 mean of x. So 1 minus 2 whole squared, which is minus 1 squared, is 1. I hope you will be able to appreciate after your probability statistics class what's going on here. Second one is 2x, the value of x, and mean is 2. 2 minus 2 whole square is 0. Third value 3. 3 minus 2 whole square is 1. 1 square 1. So now you have this variable, random variable x minus mu whole square in this column. Now you multiply that by probability of this. Now probability of this is basically the probability of x, because x is the initial random variable. So the probability of x is same as probability of x minus mu whole square. So you multiply this x minus mu whole squared with the probability of x. Then what do you get? You get all these values: 1 times 1/4, 0 times 2/4, 1/4, 2/4. These are px, probability of x, and 1 times 4. So once again, to find the variance of discrete random variable, you find a column which is x minus mu whole squared. X is the values of the random variable and mu is the mean of that variable. Then you subtract, you get the deviation of the values from its mean expected value and square that, and you get the values, and then another column, multiply those values with probability of x, corresponding probability of x, and add this column. That gives you your variance of x. Question? Hello? Hello? Do you have any question? If not, Farishta Murad is taking the attendance. All right, so
Professor, I already took the screenshot
yeah,
at 5.
that's fine. Yeah. So do you have any questions as to how to find the variance of a discrete random variable?
Professor,
Yes.
the variance formula, is it or 6? What did you write there? Like for VAR X,
VAR
above the
means variance of x.
equal, is it equal to sigma square?
It's sigma
Or-
square x, yeah. It's denoted by sigma square, okay? Here is a square. It's a square here, yeah. Yeah. Yeah, so VAR means variance, or you can write only V, okay? V. So do you have any questions about how to find the variance of a discrete random variable? Hello? You guys have to talk.
Yes, Professor.
Okay.
Yes, Professor.
All right. So if you get a variance, how do you find the standard deviation? So if you want to find the standard deviation of x, also sometimes written like x. These are all important things we'll be using in econometrics. That's why we are doing it here. What will be the standard deviation of x? Huh? Hello.
Professor. Root over half.
Root over half? Really? Or square of half? Square root of half. Which one? Huh?
It's
Standard
root of
deviation is square root of.
Square root.
So what do you get?
It will be, yeah, root over half.
It will be root over half.
Okay.
Variance is sigma square. So standard deviation is sigma, right?
Sigma. So let me write sigma. Think about it. So can you hear?
Yes, Professor, but your screen is gone.
Pardon me?
Professor, your screen, we can see your email
Yeah.
screen. Becomes
Yeah, it'll be back. No worries. So it's back, okay? Yeah, so it will be 1 over square root. I'm checking, trying to find square root. How do you find square root? Is it here symbol? See, such a crap. All right, so we'll come. Now we know how to find variance and standard deviation. So I'll again ask you to do the variance of another random variable y, the one we did the mean here. We did mean here for y, which is 7. Please, at home, try to find the variance of that random variable. Note it. Next time I'll ask. And if you cannot do it, if you cannot show me how you tried, that will not be a good thing. Okay?
Yes, Professor.
So do this. Mean and variance of discrete random variable y, which we did mean, you find the variance as well. Okay. Let's say here is another random variable, discrete. Here, this a random variable, the probability function is given. Probability function is also called the density function, okay? Is given like this. A random variable x is another x, not the earlier x, with density function. What is it called? Probability density function. With probability so I was asked about this random variable x. Is a discrete random variable. How do you know? Because the probability density function f of x is given, and where x values are given here 1, 2, 3. So x can take only these 3 values 1, 2, 3. So you know that this is a discrete random variable. The probability function is given. So this function is giving you the probability of each value. Okay, so if what is the first value of x? Hello? What is
Yes,
the
Professor.
1 by 14.
what is the probability of that value?
1 by 4.
1 by 4.
1 by 14.
1 by 4.
1 by 4.
4? Oh,
14.
14. How do you say 4?
Professor, in the thing table, it's 1 by 4.
No. It's not the same x. It is another one. Find the mean of another. Do you say another?
Yeah. But Professor, where is the values? We can't see.
What is the values? The values are here. Where x equals what?
1, 2, 3.
1, 2, 3. What are the
Yes.
probabilities? This is the probability density function. Have you heard of the density function kind of
Yes,
word?
Professor.
So this is that so-called density function, meaning giving you the probability of each value of x according to this function. So what is the probability that x takes value of 1?
1 by 14.
1 by 14.
1 by 14.
What is the probability that x can take a value of 2?
2 by
1 by
7.
7.
2 by 7, 4 by 14. And then the value
3
is
by 14.
9 by 14.
9 by
3
14.
by
3
4
by
square.
114 multiplied by 3 squared.
Into 3 square.
So now can you find the mean of this random variable? Please do it.
Yes.
Do it, please. And I'll check. I'll let you share your screen.
Professor, we have to do it on screen.
The class.
If you don't, you have it. I'd like to see your screen. At least some should show their screen to see how you are doing it.
Professor, is it 1.5?
Could be.
Where is Professor?
Hello.
Yes, Professor.
So who is going to show me? Alma Ali Chaudhary. Do you have a laptop? Are you using a laptop? Anybody using a laptop?
Yes, Professor.
So can you show? Can you share your screen?
Professor, I have done on my rough copy.
Your?
Rough copy. Like I haven't done on the laptop.
Okay. Anybody did it on the laptop? Any Excel sheet or anything?
Professor,
Lucky.
Professor, we cannot do math in our laptop.
Really? You cannot do math in a
Professor, we cannot do math in our laptop.
Really? What kind of laptop is
Yes,
that?
Prof.
You don't have Excel?
Professor, I am.
You don't have Excel?
Professor, it will take
Yes,
time.
Professor, but I am.
Huh?
Professor, it's
Professor,
time.
I never did. That's why I faced problem.
You have never done any Excel?
Professor,
Yes?
if you do in the laptop, like it takes
Professor,
time.
I
That's
have
why.
done. This is math. That's why I
See, this class is heavily based on this type of practices. Okay, if you do it on your own, that's fine. If you don't do it, that's will be difficult for you guys later on. If you say you have never used an Excel sheet, spreadsheet, that's not acceptable. What did you do in the probability statistics? Okay.
Professor, we did, but Professor, I have a question.
Yeah.
So during our exam time, how we will do our exam by? Can we write on our notes and then send it the photo to you, or we
Depending
need
on
to
what
use?
type of exam you are giving, okay. Mostly I'll try to do it. You can do it anywhere, your notebook, blah. But this course is not like that. This course you have to use your software extensively. That's why I'm saying, if you don't know how to use an Excel sheet, this is not a class
Professor,
to.
I know, but the
Yeah.
problem is, you know, I am living in my village home, so like a laptop connection, it's not like too fast. So I am using mobile device. So whenever I listen
No,
any
I'm not.
reports or do
I'm not asking about only you. I'm asking about the whole class.
okay.
This
So
class.
Professor, in our quiz or exam time, can we use our notebook?
Hopefully. Also, let me kind of give you a caution. This is an advanced level course. If you don't have any economic theories and you try to do this course, it will be a disaster. It's a very technical, advanced level course. Okay, so I hope in next class some of you at least will do use your laptop to show things. Okay, let me go ahead and share my result, part of it at least. So I did the mean. The mean is here. What did I do here? Expected value of X. How did I do it? I multiplied 1 with its probability, 2 multiplied by its probability, which is 4 over 14, because 2 squared is 4, and 3 multiplied by 3 squared, which is 9 over 14. So I added and I got 36 over 14. And what did you get? What is that? Hello? What did other get? Hello? Anybody tried this? Hello? Are you guys here?
Hello.
Yes.
Professor, the answer will be 2.57.
2.57. It will be 2.57. Anyways, whatever it is. So this is how you find it. Okay. Variable value multiplied by its corresponding probability. So if you see now, any questions so far before moving? Somebody.
No, Professor.
No questions. Somebody dropped
No.
in the chat box.
Professor.
Yeah.
Few people were writing in the chat box that they are present and stuff. So like I have taken the screenshot as you told me to, but like I'm not sure what am I supposed to do.
What's going on now?
In the chat box, few people were writing down that like they are present, but I have taken the screenshot as per your instruction at 5. So like I'm not sure what am I gonna do now.
What happened to those people?
I think they were not present at 5 p.m. or something like that, like when I was taking the attendance, but now they're here, so they want me to record the attendance. What should I do?
Guys, it has to be clear. If you show up later on, you will be reported as absent. I cannot do it all over the class. If you come like half an hour later and you ask to add you, that will not be fair. So, okay, for the last time, Farishta, please add them for the last time today and then later on. we'll be strict. Okay.
So Professor, should I take the screenshots again?
Yeah, just take them. Yeah. So make sure they are there. 42 people are present now. All right. So,
Professor?
yes,
Professor?
yes, yes. Hello. If somebody is trying to say something. Hello.
Sir, I got the answer.
Huh?
I understand.
You got the answer? Hello?
Hello?
Yes. Yes. Are you guys with me here? Can you hear me? Hello?
We can hear you, but not good.
Yeah. So now, do you have any questions as to how to find the mean and variance of a discrete random variable? Please,
No, Professor.
if there is no questions, then I have a question for you. Tell me how you check that this is a density function. How can you be sure that this is a correct density function? Hello?
Yes, Professor.
How do you check that a function can be a density function?
Is that for having a square? I'm not.
Go ahead, loudly.
Is that for having a square?
Having what?
Square?
Because of the square, you know, this is a random, this is a density function. Is it because of the square? Any other thoughts?
Professor, what about continuous random variable?
No, forget about continuous. First, tell me, here is a discrete random variable, and they're saying this is a probability density function. How do you check that this is actually a probability density function? How can you be sure?
If it is less than 1, like
Clearly,
within
clearly.
the probability,
Tell me clearly.
if it is within the probability range,
Yeah.
then it is a density function.
If it is within the,
Probability range,
what does it mean?
like probability should equal to 1, right? So like if it is within that, I guess, like I'm not sure though, like just I guess.
Yeah, even if you are not sure, you are almost there. Okay. So first thing is you have to check whether any individual probability is going beyond 1. Okay, or if there is any negative value. Let's say, is there a negative value? No, because it's a square. So probability is always here positive, but is any probability going beyond 1? You check. You check that the first one is 1 over 14. Second one is 4 over 14. Third probability is 9 over 14. So each probability is less than 1. Plus, you have to check whether all the probabilities add up to
1.
Okay.
Professor, can you repeat again, please?
So first check is whether each probability is between 0 and 1. Okay. So what are the probabilities here? There are 3 values of x. So you will get 3 probabilities. For one, probability is 1 over 14. Is it between 0 and 1? Hello?
Yes.
Yes. Second probability of 2 is 4 over 14. Is it between 0 and 1?
Yes.
Yes. Then probability of 3 is 9 over 14. So is it between the 0 and 1 interval? Yes. So first
Yes.
First condition is fulfilled. Second condition, add all the probabilities. How many probabilities are there? 3 probabilities. 1 by 14, 4 by 14, and 9 by 14. Add these 3 probabilities. What do you get?
1.
1. If you get 1, so these are the 3 probabilities. Probabilities. 1 by 14 plus 4
2
by
by 7,
14 plus 9 by
14
14
equal to 1.
equal to 1. That is telling you the summation of probabilities should be 1. You check these 2 conditions, each probability between 0 and 1, and you then add all the probabilities and find whether summation of all the probabilities is 1 or not. If it is 1, both the conditions are fulfilled, it can be a probability density function. If it's not, then it cannot be a probability density function. Everybody with me here?
Yes, Professor.
All right. So, and then again for you, homework, find the variance of this variable. Write down the density function, please. Write down this. The density function, random variable, then with density function this, and where the values are 1, 2, 3. Please write it down. Find the variance of that discrete random variable at home. I'll check in the next class. You have to be active in this class. Please. While
Professor, can you send us this?
I can, but you don't need that to find this, okay? I'll send the script, but you write it down right now.
Fine.
The variance of this random variable x, where the density function is this, and x takes the values 1, 2, and 3. Did you write down?
Yes, Professor.
All right, good. Now we can talk about continuous random variables. Continuous random variable. What is a continuous random variable? As someone said, continuous random variable can take values over a range. Over a range. So it can take values, integer values as well as fractional values. And density function. So here is an example. Here is an example of a this continuous random variable. So this is another variable, not that x. Okay, it's a continuous variable with the density function 1 over 9 whole square, 1 over 9 x squared. However, x here is from 0 to x can take any value from 0 to 3. All right, basically less than 3. Not 3 exactly, less than 3. So, so this is a continuous random variable that can take values over this range. Now the question is how to find mean and variance of this random variable. I'll do mean and I'll let you do the variance. I'll keep it for you because you have done the probability statistics. So if it's a continuous variable taking values over a range, you maybe for the first and last time we are doing this integration here in this class. So how to find the mean? The formula is integration over the range it takes 0 to 3. It's a definite integral, and very similar to the one we did. X times, there it was x times f of x, here x times f of x dx. In a discrete variable, you add. In a continuous variable, that is the continuous counterpart of summation. Remember, integration is nothing but the summation for a continuous variable. Over the range, the variable takes the values. So integration from 0 to 3 x times f of x. Now, I hope all of you know a little bit of integration. Is there anybody who did not see this weird sign? Hello?
No, Professor.
Everybody has seen this weird sign. It's called integral sign. So here the range is 0 to 3. Whatever the range, here our range is 0 to 3. If it could be 0 to 55, it could be minus 5 to 99, or minus infinity to plus infinity. Whatever the range the variable can take, you have to integrate over that range. And what is here inside? The variable times that density. So I have done this here. Mean of x, again is mu, expected value of x, or mu you can say. And I did the integration here. I multiplied through, because it's x star 1 over 9 x squared. That is the density function. I multiplied through and I got 1 over 9 x cubed. And that gives you, if you do the integration, it gives you x to the 4 over 4. 1 over 9 x to the 4 over 4. Ranges, I could not write it here. Range is from 0 to 3. And if you know how to do a definite integral, you will see that the result is 9 over 4. Any questions about how to do the integration?
No, Professor.
So take a look at that. Take a look at that mean again. I'll pause here a couple of minutes. Anybody has any?
Professor?
Yes.
Professor, why are we integrating here? Can you explain that again?
Integration is nothing but the summation in a continuous variable time, okay? So the way here, remember we did the summation here? You see the summation we did here?
Yes.
For a discrete variable, it's summation. For a continuous variable, it's just integration, because you cannot add each value 1.1, 1.11, 1.111, and so on. It's a continuous. So the calculus way of summing this thing is just to take the integration. If you recall your calculus course, you will see that integration is basically area under a curve. If it's a definite integral, it's area under a curve. We will show when we do the normality, then we will show that what integration means there in a curve. Let me see if I have some things. And so summation and integration are basically similar things. One is it in discrete variable, another one is for continuous variable. Let me see if I have, I can open the book and I can show you. So I don't know. The book is not opening. Oh, here it is. So you can use this formula for variance. Instead of summation, you are doing integration here, range from 0 to 3 in our example. Also, you can do this shortcut. Expected value of x squared minus expected value of x whole squared. Can you see this shortcut? Some people love this shortcut method.
Yes, Professor.
Okay, so look at this shortcut carefully. One is expected value of x squared. Another one is expected value of x whole squared. Are they same?
No.
Huh?
No.
Okay. Do we know one part of it?
Yes.
Which
we know
part?
the expectation of x, the second part.
We know the second part already. Expected value of x, which is 9 over 4. And you can square that. This part you have to find. Same way. Instead of expected value of x, you find expected value of x squared. So you will have x squared here and f of multiplied by f of x. Then you find expected value of x squared. And then if you subtract this from that, you will get the variance of x. Please do it. I'm giving you all these things so you practice variance of x. I gave you the result here, variance of x, 243 over 45. But it's in the book, you can check with the book, you find it.
Professor, can you go up a little?
Yeah, where?
Yeah, here.
Which part?
No, Professor, this part.
Huh?
Yeah, it's okay, this part.
So you have any question as to how to find the mean of a continuous random variable and the variance of a continuous random variable?
No, Professor.
No. So far, I'll show just one more thing from the book. I'll try to show from the book. It's tedious for me to write these things. So what we did is basically, these are the important stuff we are doing. Random variable, probability assigned, probability distribution, and the mean of the distribution, variance of the distribution, standard deviation of the distribution. We did it for discrete variable with even one with the density function as well. How to find the mean and variance and standard deviation. Then we said, okay, there might be continuous variables. Basically, most variables will be continuous in our case. And then you find the mean of a continuous random variable if the density function is given. And we will show what density function means in a normal context, because that is our goal. And the mean of the continuous random variable is an integration of the product, and then variance of the continuous random variable if the density function is. If you find the mean, you find variance, you can also find standard deviation. So before we move forward, you guys have to do the variance of the variable from dice throw and the variance of this discrete random variable with density function on this and variance, and then you find the variance of this continuous variable with this density function and over range 0 to 3. Please write it down, okay? Find the variance. Before next class, please practice them. All right, then if you know expected value, if you know variance, we will show you some properties of expected values. And These are operators, and you can use them. Our professors used to force us to do these operators. Yes, I guess. Yeah, here's this is the value thing we used.
Professor,
Yes.
which chapter is this lecture from?
This is basically appendix, statistical appendix.
Appendix.
Yes. But the book is more elaborate than what I'm doing. The only the skeleton of the things we have to do.
Can you specify the page number where you?
No. It's, you check. It's the appendix in the at the end of this thing.
Sir, could you please repeat what was the homework?
What repeat? Which one? Which one you want me to repeat?
The homework you have given.
Which part? Tell me.
Just a few minutes ago, you talked about homework here. The probability density function.
Yeah. Before we go, we will summarize again. Not much. We did not do much today, but yeah, I have to go slow. I have to make sure you understand this stuff. Not only the formulas, what is going on in between. You have to read between the lines. Expected. I'm looking for the property of expected values. Here, properties of expected values, okay? So as we did probability expected value, the will not all, the others we did not talk. If we need, we will come back. Here.
Professor?
Yes.
In my screen, I can see like the continuous random variable page one.
Oh, really? Okay.
Yeah, are you showing something else?
New share. Let me do new share. Can you see now?
Yes.
Huh?
Yes,
Yes.
Professor.
So properties of expected values. Expected value of a constant will be the constant itself. Okay, so first rule, expected value of C will be C itself. Expected value of mu, what is mu? Hello?
Population mean.
Population mean, parameter. So expected value of mu will be mu itself. All right, remember this. Expected value of any parameter, any constant will be itself. Number two, if A and B are constants, then expected value of AX plus B is a linear combination of X. What is X? X is random variable. If x is a random variable, then if you multiply the random variable as a constant and also add some other constant with that, you will get this a expected value of x plus b, because expected value of b will be b itself. Expected value of ax will be a expected value of x. Any questions about these two? These two are most important for us. Expected value of a constant is that constant itself. Expected value of a linear combination of a random variable like ax plus b, a is a constant, b is a constant, then expectation will be only on the random variable. If you know the expected value of x, you can write it here. But you will be, that expected value will be multiplied by the same way here you will get it. Exactly same. And number 3, obviously, if you know what is the dependent and independent random variables, then you can say expected value of 2 independent random variables, product xy will be expected value of x and expected value of y. So that is this so far what we did, property of expected value. Also, we will have a property of variance. This is the formula for variance. Remember, expected value of x minus mu whole square. Obviously, this will be expected value of x square minus mu square. The shortcut formula we have used here. More importantly, 2 and 3. Variance of a constant. Variance of a constant would be, hello?
Yes, Professor.
Variance of a constant will be 0. Why? Because a constant cannot vary. So the values are there is only one value. So how do you find deviation? Deviation will be always 0. So variance of a constant is 0. And number 3. Number 3 is very important. Number 4, as we go, we will learn. Number 3, if a and b are constants, then variance of ax plus b would be, first part, variance of ax would be a square variance of x plus variance of b would be 0, because variance of a constant is 0. So second part vanishes. Sometimes if you see it first time, it looks odd, but it can be proved. Variance of ax would be a square variance of x. Second part is a constant. It does not have any variance, 0 variance. That part vanishes. Okay. Hello?
Yes, Professor.
So I guess so far so good. We'll talk about covariance in the last class little bit. Also, we'll move on with probability. And look at the appendix of your textbook, statistical appendix. There are 3 or 4 appendices. One of them is statistical appendix. What I did mostly from that appendix, you check, and we'll go continue this probability statistics review as much as we can, but we have to pretty soon start our main job, the econometrics. So any questions?
No, Professor. Professor, can you please share all the class materials? Like we got the book, but we got the book, but the
you
recording.
First read the book. Yeah, I'll share. But you can. There is no skip from the book. Remember.
Yes, yes, yes,
yeah,
Professor.
The lecture sheet is just a precise thing. What we did. Yeah. So okay. So what we did today?
Professor,
Yeah.
Professor, I didn't get the book.
Yeah. I'll resend. To if your name is on the list, I'll send it to you. If not,
Okay, Professor.
make sure you.
Professor, I think you only sent to the old ones. I don't think you have sent to the ones
Pardon
who
me?
were added to this class.
Hello.
I don't think you have sent to the ones who were added to this
I'll
class.
send to everybody.
Thank you, Professor.
All right. So I hope you'll understand what we are trying to do in this class. I also try to read between the lines. That is important. Yeah, why we are doing it is more important than how to do it. All right.
Yes, Professor.
So I call it a day. We'll see you on Sunday.
Thank you, Professor.
Take care, Professor.
Stay safe. Take
You
care.
too.
Bye.
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 Professor,
Yes.
I wanted to talk to you about the inter-micro position. You emailed me today.
Share. Stop share. Okay. Yeah, others please leave. Yeah, who wants to talk?
Professor.
Shabasti.
Yeah.
Who wants to talk? Please. Yana,
Professor,
you,
yes.
you.
Professor,
Yeah.
I have sent email. Can you please check?
Sorry.
I have sent you an email. You told us.
Okay,
to send
I'll
me
check. I'll check. I'll check.
Thank you, Professor.
Professor, I also wrote an email
Yana,
regarding
yes.
adding the course. Yeah.
Yeah. What is it?
I wrote to you an email about adding this course.
Yeah. As long
Can
as
you
I have
please check it
space,
out?
I'll take. If I don't have a space, it's already 38 in this class. All right. Yeah. And Sravasti?
Professor,
Yes.
about the intermediate micro TA thing.
So there will be 2 sections. I'll give you 1 section. Okay.
Okay, Professor.
Yeah. I'll let you know. Yeah.
Thank you, Professor.
Yep. Yeah.
Hello, Professor.
Yeah. Afia?
Professor, I was sending email yesterday night because of taking 5th course. So I need your permission as I got 3.35 GPA.
So what is the 5th course you are intending to?
Just labor economics. I want to take that one.
You first talk to the professor.
But Professor, I want to say one thing. But in this
No.
semester,
You have to first make sure professor are taking you. Start taking you in their classes.
Professor, I was sending email, but you were not responding. That's why I'm just talking it now.
You have to give me detail. You want to take one course.
Yeah.
If your professor
Yeah.
doesn't know and I let you, I permit you. What is the point of my
Okay. Thank you, Professor.
Yeah. All right. Hello.
yes, Professor, I'm telling that no one can take 5th course in this semester until like all of the students get 4 courses.
Yeah.
So
If
Miss
that's the case-
Anika mentioned
if
in the
that's the
email.
case, what can I do? But yeah, but if you, what is your 5th course?
No, it's not my 5th course. I'm talking about Afia. She was talking about this. That's why. And my
Yeah.
question.
Why are you talking about Afia? Let Afia talk about that.
Professor,
Who is talking?
Professor, it's me, Alpana Akhtar. I want to talk right now about me.
About what?
Professor, I send you several emails. So
Yeah.
right now also I send you an email and I told you that I got only 1 course this semester and Miss Anika told me to continue the class and
Which
I hope
class?
you will
Which
add
class?
this class.
Were you in the wait list?
Yeah, I'm on the waiting list.
Okay. And what other courses you were in the wait list?
Another one is a intermediate micro.
So did you get that course?
Yeah, in the section 2,
Yeah.
I got it. Only this course I got, and
Yeah.
another, like all 3 courses are on the waiting list. So I hope you will add me because I'm on the waiting
I'm not
list.
sure. It's already 38. Okay. I'll check today how many people are still on the wait list and attending the classes.
But professor, at least we should get 4 courses this semester, right?
Yeah, I see. I have already given you like the intermicro, okay, second section. So now let other people also do their part. Let me see. Let me see. Okay. Okay. Anybody else? No. All right then. Administrator, is it Iftikhar? Hello. Hello, Iftikhar. Are you there? All right. If he doesn't want to talk, then what to do? I'm going to end the meeting for a